Hey everyone, and welcome to this explainer. I'm absolutely thrilled to have you here today because we're going to unpack a topic that is incredibly dense, highly debated, and honestly utterly fascinating. We are diving into the deliberate manipulation of the Earth's climate. Think about it. Humanity is looking at our warming planet and asking, can we actively build technologies to cool this whole thing down? So let's just jump right in with a massive question. One that is rapidly shifting from the realm of science fiction straight into serious, well-funded academic research. For decades, the whole conversation around global warming has been laser-focused on prevention, right? Cutting emissions, ditching fossil fuels. But as temperatures just keep creeping up, scientists are exploring a totally different approach. Can we engineer our way out of this? Like, can we physically rebuild the systems of our atmosphere and oceans to reverse the damage? To get a grip on this, we really need to define what we're looking at. Geoengineering, which you might also hear called climate engineering or climate intervention, is defined as deliberate and large-scale interventions in the Earth's climate system intended to counteract human-caused climate change. I want you to really zero in on two words there, deliberate and large-scale. We aren't just talking about seeding a few clouds to make it rain over a specific farm. No, we're talking about global, planetary-level interventions designed to alter the trajectory of the entire Earth's climate. It's huge. So, here is our planetary toolkit for today. First, hacking the climate. Second, removing carbon dioxide. Third, reflecting the sun. Fourth, saving the glaciers. And finally, the global rulebook. Let's get into it. Section 1. Hacking the climate and the baseline science behind it. Right off the bat, there is a crucial point we need to establish. And honestly, this is an absolute consensus among major scientific organizations from the U.S. National Academies of Sciences to the Royal Society. These tools are generally considered a possible complement to, not a replacement for, efforts to reduce greenhouse gas emissions. Listen, no credible scientific body is out there saying geoengineering is some magic silver bullet that lets us just keep emitting carbon with zero consequences. It's more like a potential backup system, a complementary set of tools to use alongside deep, sustained emissions cuts. The scientific community, including the IPCC, basically divides these tools into two distinct camps with vastly different mechanisms and risks. On one hand, we have carbon dioxide removal, or CDR. Think of this as treating the cause. It acts like a giant vacuum cleaner sucking up the carbon mess we've made in the atmosphere. On the other hand, we have solar radiation modification, or SRM. This is treating the symptom. It acts like a global sunshade, bouncing sunlight back into space to cool things down. Which brings us to Section 2, removing carbon dioxide, the vacuum cleaner. Let's look closely at how we can actually scrub the atmosphere. You constantly hear the phrase net zero emissions thrown around in climate policy, right? Well, achieving net zero requires deep emissions cuts first, obviously, but then we have to use carbon dioxide removal. To counterbalance the emissions that are just incredibly difficult to eliminate, think certain heavy industrial or agricultural processes, we have to physically take CO2 out of the air and lock it away durably in terrestrial, marine, or geological reservoirs. CDR is literally what puts the net into net zero. So, what's actually in this land-based toolkit? It is a wild mix of the deeply natural and the highly industrial. We've got nature-based solutions like afforestation and reforestation, which is planting massive amounts of trees to draw down carbon, although, side note, research shows that effect can sometimes be temporary. We've got carbon farming, storing carbon directly in agricultural soils. Then we move into the heavy tech, bioenergy with carbon capture and storage, or BECCS, and my personal favorite, direct air capture. This literally involves building massive industrial machines that suck ambient air through giant filters to pull out the carbon dioxide so it can be pumped deep underground. But hey, the Earth isn't just land, right? The oceans are a massive part of this toolkit too. Scientists are researching interventions to help marine ecosystems absorb even more carbon than they naturally do. We're talking ocean fertilization, adding nutrients to the water to stimulate carbon-absorbing phytoplankton. They're also looking at ocean alkalinity enhancement, restoring wetlands, and utilizing blue carbon approaches. Blue carbon focuses on coastal ecosystems like salt marshes and mangroves, which are just unbelievably efficient at locking away carbon dioxide. Actually, let me clear up a really common misconception here. You have probably heard of carbon capture and storage, CCS. Now, CCS is not regarded as carbon dioxide removal, and therefore it is not geoengineering. Why? Because CCS is attached directly to a pollution source, like a coal power plant. It captures the emissions before they ever hit the air. It just stops new emissions. Geoengineering and CDR are about vacuuming up the historical pollution that is already up there circulating in the sky. Make sense?
All right, Section 3, Reflecting the sunshade.
We are shifting gears now from the vacuum cleaner to the sunshade. This is solar radiation modification, SRM, and it is entirely focused on cooling the planet by bouncing sunlight back into space. The proposals here are wildly ambitious. They honestly sound like something straight out of a sci-fi movie. The most researched method is stratospheric aerosol injection, where fleets of high-altitude jets or tethered balloons would spray tiny reflective particles into the upper atmosphere to scatter sunlight. Then there's marine cloud brightening, spraying sea salt into low marine clouds to make them more reflective. And at the absolute extreme edge of engineering, there are literal proposals to build massive space mirrors to physically block a fraction of the sun's light before it even reaches Earth. No way, right?
But we have to return to our anchor point here. That not a silver bullet concept? It absolutely applies. Solar radiation modification does zero to remove the actual greenhouse gases choking the atmosphere. It doesn't stop ocean acidification, it doesn't clean the air. It is purely a mechanism to complement mitigation by artificially lowering global temperatures and, well, buying us some time.
Moving to Section 4, Saving the Glaciers, our planetary icebox.
Let's look at a highly localized third tool that focuses entirely on the Earth's most fragile environments, the poles. So why focus just on the ice? Well, the stakes are literally existential. Scientists want to intervene here because melting ice threatens to trigger massive, dangerous climate tipping points. When we lose white reflective sea ice, we suffer ice albedo loss, meaning the darker ocean absorbs more heat, which causes even more melting. It's a vicious cycle. There's also the terrifying risk of accelerated glacier flow causing massive sea level rise, and thawing permafrost acting like a ticking time bomb, releasing vast amounts of trapped methane, which is a greenhouse gas far more potent than carbon dioxide. To stop these feedback loops, researchers are dreaming up some unbelievable engineering marvels. Now, these are in very early research stages, but they include thinning high-altitude cirrus clouds to let more trapped heat escape from the poles. They're looking at modifying surface albedo by literally spreading reflective materials over the ice to shield it. They're exploring draining subglacial water to slow down sliding glaciers, and perhaps most mind-blowing of all, they're investigating the construction of massive seabed curtains. Just think about that. Giant, engineered underwater barriers installed on the ocean floor, specifically designed to block warm ocean currents from melting vulnerable ice shelves from below. It is a staggering level of intervention.
Which leads us to Section 5, the Global Rulebook, Governance and Ethics.
Okay, so we've unpacked the science. We have this incredibly powerful toolkit. But this brings us to the hardest part of this whole explainer. Who actually gets to touch the Earth's thermostat? Before we even look at treaties, we have to look at the massive ethical hurdles. The big one is the moral hazard objection. Critics have a very real fear that pouring research and funding into geoengineering could inadvertently undermine the incredibly difficult political work needed to actually cut emissions today. The worry is that these technologies might just give heavy polluters the ultimate excuse to keep emitting, basically banking on a technological miracle to save us all later. Because of these enormous risks, the international community has been trying to write an instruction manual for decades. Let's walk through this timeline. Back in 2010, the Convention on Biological Diversity established a non-binding framework saying geoengineering needs strict scientific justification and regulatory oversight. By 2013, the London Protocol adopted a legally binding amendment specifically to regulate marine geoengineering, like ocean fertilization, demanding strict assessments before anything proceeds. Fast forward to 2023, and these very same bodies are now issuing stark warnings about the serious environmental risks and massive scientific uncertainties that still surround these techniques. Ultimately, the bottom line from major institutions like UNESCO and the World Climate Research Program is that we need extreme regulatory oversight. The global scientific community is demanding far more open knowledge sharing, transdisciplinary research, and incredibly strict international permits before any real-world experiments take place. You just can't hack the sky without global consent, right? And that leaves us with one final, incredibly profound question to wrap up this explainer. As we draw plans to manipulate Earth's thermostat, are we actually ready to be the architects of our own climate? This planetary toolkit is rapidly moving from theory to reality. These tools are unimaginably powerful, but humanity as a whole has to decide if we are responsible enough, united enough, and wise enough to actually wield them. Thank you so much for joining me for this explainer, and I highly encourage you to keep questioning and keep learning about the science that is quite literally shaping our future.